First of all, I'm really honored and it's such a pleasure to be here. And iStructE has been a longtime supporter, and Ian is a mentor and such a hero of mine. So thank you for letting me come join the evening. I actually currently am working on my British accent, and I live here in Oxford. So if you want to give me some words of encouragement, I'll maybe throw in a few subtle moments of working on it, but I still am terrible. But anyway, I really wanted to take the opportunity to be a bit more informal tonight. And I know that we have a lot of friends, a lot of folks that know us, a lot of people that have built, and to get in a little bit more about why we design for the rural last mile. And this is such a passion point for me. I think designing structures anywhere in the world is such a noble cause, and it is the kind of career that I'm passionate about getting young people excited about. And I believe designing for people in the rural last mile that are the most forgotten will help to tell the story for the next generation of engineers to come in and to do the work right here in London, right there in Denver, as well as in the rural last mile. So I think what I'm hoping to have a conversation tonight is more about the role that this work has in serving the people we're meaning to serve, but also trying to think, how does this translate into inspiring an entire next generation of people that can see that engineering really does help people. So Bridges to Prosperity is the world's only organization to focus on solving this crisis on a global scale. And we're not going to be able to do this alone. This is a challenge that is pretty significant. It's global. And in my belief, the more people and the more organizations and the more thought partners that we have trying to think about how to connect rural people, the better. I like to think that Bridges to Prosperity is a convener. And so in a bridge, in the literal sense, we're also trying to bridge together different organizations to provide resources, to provide training and best practices, and to create an army, not only here in the UK or in the US, but perhaps more importantly in Rwanda, in Uganda, in Haiti. So the challenge that I speak of is big. A lot of people outside the engineering sphere and in it know that there's 1 billion people that don't have access to safe drinking water. And there's, actually I shouldn't quote these because I don't actually know them off the top of my head, 2.5 billion people that don't have electricity. There are 1 billion people that don't have toilets, all these big, big numbers. But if you think about it, it's a Venn diagram. And the people that don't have adequate schooling, that don't have adequate health care, that don't have electricity, are all generally the same people. And those people are generally the folks that don't have access. So if you can imagine, and so many of you guys have spent time in these communities and have actually built these bridges, I think it's a first line indicator of how we're going to start to connect the rural poor. And we don't think about a bridge as solving the problem, but to start to think about how we can connect these folks, the 1 in 7 people in the world, how do we connect them to the services that already exist? And also encourage a flow of goods and ideas in and out of that community that will help to bring other kinds of resources, whether it be potable water, education, healthcare. And I think, again, for so many of us that have had the tremendous pleasure of seeing the world and to understanding this problem firsthand, it's really humbling. And there's something so grounding about being like, would I send my kid across that bridge to school? And then to realize, actually, that community is quite privileged because so many communities don't even have a bridge to start with. And as we think about the 1 billion people, or the 1 in 7, I really think that it's important to think about this as it relates to something that we can actually help to solve. There aren't 1 billion people that need a bridge, I would think, but there's a significant portion of them. And if we think about mapping all of the rural rivers in all of the emerging economies in all of the rural areas, we believe that there's about 100,000 places where a bridge would provide catalytic change for every single person in that entire region. And I think what's kind of wild is sometimes these kinds of lack of access catch the media attention. Like this photo, I think we had originally found because BBC covered some sort of really wild ride. Kid goes to school in a bucket, you know. And there's a little bit of, like, wow, that is a shock factor, like an awe, an admiration. But no one ever goes on to say that this is the lucky community, guys. This means that they're actually right now being able to get goods and services across. And so I really want to encourage all of us tonight, and as we move forward in doing this work or just observing what it is that working in rural communities is all about, is to think about everything is something of an intermediate technology. So at one point, folks going to a healthcare clinic in this village in Rwanda were swimming. And at some point, there were logs that were able to be put across. And that's a huge technological advancement if you think about the binary of having access and not. But if you think about how many of these places that we've worked in, these structures get washed away or are underwater for several months a year, and you start to really build up a repertoire of, well, maybe if we build a pedestrian bridge that's going to withstand all of the floods that ever happen, maybe someday they'll also have other kinds of infrastructure here. And start to think about it in time scales. And that's something that I'm really excited about, is that we as an organization and as a global community of people that want to connect the rural last mile, we're connecting people and accelerating the pace of development. I fundamentally believe that what we're doing is not that complicated. And I'll tell you more about it. We'll get into the design stuff in a little bit. I know, technical lecture, we'll get techie. But you know, the why is so important. We are trying to accelerate the pace at which these rural communities are connected safely. And we believe, as a fundamental principle, that when those communities are connected, they are going to be able to evolve and have new access and new points and new economic and health opportunities that weren't there before. And that's because we all know, hopefully, structural engineers, bridges connect people. And people are brilliant. I always like to think about, you know, what are some of the most genius ideas that I've ever come across? And who are the people that tinker and are like, man, they're smart? They're almost always the folks in the communities or anywhere out in the world who are out there and innovating. You know, there's this idea that, what is it? Innovation is the something of necessity. Someone want to shout that out because I can't remember it, but thank you. Yes, I should like take notes and be more formal. Sorry, but isn't that the truth? Like, if you are having to figure out how to do something, and that is how you're going to progress, you're going to tinker and you're going to figure it out. And I think the world is full of potential engineers, even if we don't name them that. That's so exciting. And bridges are such an obvious piece of human genius. And I think, like, looking historically, to be able to cross from, again, that binary, from having access to not having access, is just one of the most powerful sites. And so here's a community that is in Chameau in Haiti. And this river is currently in the dry season. And I want to talk about this structure specifically a little bit later this evening. But can you imagine living on the far side of that river and you're one of the 40,000 people that the only way to cross that river is to swim? Keeping in mind this is the dry season. I mean, can you imagine when you've got someone showing up and being like, hey, well, we could do something across that structure? That is out of this world kind of innovation. That is the aspirational quality that you can't even show pictures, you can't even bring videos. You aren't really able to demonstrate what that means until you've actually had the opportunity to show someone in real time. And that innovation for us is, I'm going to get into scale a little bit later, but when the first time we go into a region or a district, Chameau was our first long span structure out in Jeremy in the west province of Haiti. People don't really get it. And if we're thinking about, we don't want to just connect one river, but we want all people in an entire region to be able to be connected, you have to go in there and you have to do some of the hard projects up front when no one really knows what you're going to be up to. And we've got the cables going across the river, and you're like, walking them down the 10 miles or whatever it's going to be from wherever you drop them. And you got these crazy giant pipes that everyone says you need to have pipes, and they're blue. And what are these things? You're like walking them down, and they're heavy. It's not until that moment when the towers go up and the cables thread that it's like, holy moly. That is how we're going to get across this thing in the future. And that moment of genius is inspirational. I think it's inspirational certainly for myself, hopefully for those of you that have been part of this program before. Definitely inspirational to people that now have an entirely new life. The 40,000 people that rely on the Chameau Bridge to be able to go to everything from healthcare to a market, those people are forever changed. And I think what's really exciting is, for whatever reason, we landed on something as structural engineers that can really demonstrate the ability for human connection. And I think that that's really exciting. Especially when you're in places where there's a bit of an awe factor. I remember shooting, this is in Chaquicocha in Bolivia, and I remember you're talking to the municipality and the district, and you're starting out with where are the areas where communities have requested structures? And that's always how we do business. It's not us flying in and saying you want a bridge. It's where is it that is needed? How can we help build capacity within the government? And this particular mayor is talking about this area, and he's, it's like a couple hours away, and my Spanish is not that great, so I'm like, I think I'm understanding it's a giant gorge, but unclear, we'll see. And we arrive, and I was like, I don't even know how we're going to get the sight line. Who's going to go over and hold the stick? I'm not doing that, heck no. And if you can actually kind of look, is there a pointer on this guy? So essentially, I'm on the near side. It's about 2.5 hour drive up in this little direction. Eventually, you can, if you go far enough, you can get down to something more of a stable kind of crossing point down there and all the way back up. Something close to 45 minutes. And I was like, I guess I could do that, but you guys are going to be waiting quite a while because we're also at 11,000 feet. I'm so bad at meters, sorry. That's really high. That's above tree line in Colorado where I'm from. So it's you're high, you're sweating, you're panting, you're trying to get up and down, and you got to go get someone to get a survey stick over there. And these are the challenges of when you're showing up and saying, when you tell someone, we're gonna have a structure that's going to connect you for the next 30 years across this span, there's just this disconnect of, really? How is that gonna work? I think you're crazy. But I've seen this over and over again, and I probably overdid the photos, but I think what's exciting for me personally is when I got involved, I was like many of you. I was in kind of that place in life and thinking about, well, what could I be doing with my engineering skills that would help humanity? And that could be right there in Iowa where I grew up. That could certainly be in Colorado where I was going to graduate school. But there was just some sense of what am I going to be doing with my day that's going to be helping people? And I hope all of us know everything we do is about serving society. Every single day. That is why it is such an honorable profession. But it's hard to demonstrate to a young 2-year-old who's just graduated that all the physics and all the math, and even if you love thermodynamics and physics and dynamics, how does that translate into people? And the first time that I built a bridge, it wasn't this one per se, but it was similar. I had that profound sense of this is why we do what we do. And about a decade later, we're building something much more complex like this. It's actually not that different. It's a structure that is helping serve people. And I think what's really exciting for me personally and for the entire organization, Ian is our chairman, has seen us go through an evolution where we really used to talk a lot about the bridge. We used to talk about how do we improve the design details every single day? How do we republish essentially a standard of best practices every year? How do we go bigger, go longer, go more efficient. And what I'm here to share with you guys this evening is a little bit of why we are moving away from that. And it still takes a global army, and it certainly still takes a lot of engineering. But as we start to pivot and start to think about designing for the rural last mile, we're talking about innovation that is not going to be structure by structure. And we have such a distinct privilege in the developed world to have resource, to be thinking about having signature projects that are unique in every place and are prescribed exactly to the fit in the community and exactly what everyone could ever dream of, hopefully, when budgets allow. But when we're thinking about designing in places where you're walking cable in, how many people have held cable, 1-inch cable? Yeah. Okay, that's about all the British West people. Yep, thank you. It's not nice. It's not as ductile. It's not as movable as you might think it is. It's heavy. It's greasy. It's getting all over your pants. And you're thinking about innovation through the lens of how are we going to get this super heavy cable up and lifted. And we're thinking about innovation in terms of how are we going to be able to maintain a level of structural integrity when you're mixing concrete in a volcano method. Also, one of the more fun, not fun things to do. Because I have the time, I'm going to tell more stories. So one of the first things I did in Peru, so I'm 21, I've taken a civil materials class, and really was like super excited about having my scale with my gravel and having knowing what my sand ratio is going to be, and I knew exactly the scale of the water was going to be, and I'd even written a little paper, the pre-construction plan for my team going to Peru. I'm thinking I'm really bright. I'm like, oh man, this is way ahead of the game. And then I showed up and I was like, well, these guys are already mixing. We haven't even arrived. How are we going to do cylinder tests on that? This is not going well. I'm in panic mode. I don't have any professors around. I don't know, everything I've read, this is not right. And, lo and behold, you kind of start to realize that a lot of things that you're taught are correct, and a lot of things that you want to apply have to be learned. And I think that that's something that's really important of a lesson in this kind of work that is really great for young engineers in particular, is just even to conceptually understand the difference between measuring by weight and by volume. So if we're going to improve quality in a batch, that's certainly not going to happen because I all of a sudden in a manual somewhere in the 20th page prescribe a different kind of weight measurement. It's going to be having photos and diagrams of 3 buckets of water to, and so it's going to be buckets, it's going to be wheelbarrows, it's going to be shovels, it's going to be how many times do we shovel the one pile into pile 2 and how many times back to pile 3, and how are we going to teach what a slump test looks like from something that can be done with a soda bottle, and to be thinking in innovation in those terms. And that was revolutionary for me as a young engineer, was to think about how we can use those skills of problem solving in everything we go to school for. Not only identifying the problem, but coming up with a solution. And it starts right there with mixing your concrete. And I think it was also always helpful for me to keep in mind is when we design things, it's what is the motion to get that there? So, going back to the cable, I remember our founder, Ken France, he gave me the tall task of going and building a 95-meter structure in Ethiopia. It was one of my first big projects. And he's like, you'll learn enough Amharic just by sleeping in the tent. You're going to be all right. But he's like, the biggest challenge you're going to have, Avery, is to figure out how to get that cable across the Nile. Silence on the other end of the phone. Talk to you later. I was like, okay, I've touched that cable before. That's not actually as easy as one might think. So I started, toying. I started using that same level of iterative, identifying the problem, thinking about different solutions, talking to people, drawing schematics, going to the hardware store and picking up carabiners and how would you clip? But how would you get it across the first place? So that kind of thinking is actually what many of us do in our everyday lives. But when it's applied to something that I'm actually going to touch and feel, and that design idea is actually going to be me out there pulling on it, it makes a big difference. And again, I think that this is why this work can really translate really cleanly for our industry and our profession as a whole. We can provide these really interesting, creative, hands-on opportunities for people to use their creative knowledge and be able to solve problems without it necessarily needing to be 20 years into your career. I was going to tell you how I did it, but then I think you're going to poke holes because we got lots of smart people in the room. So I got all 6 cables across very safely. It took 80 people and 3 days. Maybe we'll do a Q&A question about that. So coming back to the really felt sense of what it means to be innovative in this rural last mile. The first time I was in Peru, I also was so bewildered that thing that I drew was going to take lots and lots and lots more rocks than I thought. So I was like really certain that ramp was just this big, about yay big, and it needs to be about a meter wide, And I was out there carrying rocks like these ladies for probably a week straight, and I was far inferior to every single Peruvian woman, boy, child, man. They were all like big rocks and all the things. But you start to realize that what translates from what I was doing in my little AutoCAD station back in Iowa, what that meant for me when I showed up actually had quite a profound impact. And it made me start to think about the end outcome of things that we believe are great ideas, because rocks are heavy and they take a long time to aggregate. About a decade later, I was part of this project last year. And so you can see that this particular structure is in an area where getting giant rocks is actually quite hard. So thinking about how you're going to orient the pedestals and what the size of those pedestals are going to be was quite important. But it really is a moment of pride for me, and to think about when you go from, just as a team, as a global team of Bridges to Prosperity, being able to design and build this structure is such a feat from a structural standpoint. But we're also using that same innovation and tools around minimizing rock carrying, trying our best to make it so we can get these cables up and going, and so on and so forth. But it's not the bridge. I promised you one thing tonight. What you probably don't know is how much time I'm thinking about what's not the bridge. I did my master's thesis about the bridge. I thought about how to standardize the bridge. I thought about how to do a parametric analysis, to look at all the different variations of depth, size, geometry, soil conditions for all the anchorages. How could we standardize this? How can we make it better? I love to noodle on that. But it's not about the bridge. In Rwanda alone, we have 350 places that have asked for a project, that a community has gone out of their way to ask a municipality to say, yeah, this is going to be life-changing for us. So for all of the time that we can spend noodling and problem solving, it is quite important. But we've got to start doing that same noodling and creative problem solving around getting more communities connected. And I think that's actually what's driven me to be here, to be studying for a year, is I really kept noodling, like, let's keep getting the structure better and better. But I believe in order to make global, meaningful progress on some of the world's most difficult problems, we need to start using engineers, people in this room, to be creatively thinking about how to get systems at scale. How do we do systems change? How can every single time that we're doing any of this work, how can we move the needle on making it so more people locally can build this? How can we, every time we're making a shipment or thinking about a material, can we think about replicability? How can every single time that we touch a drawing, we're thinking about how easy is this going to be for someone who hasn't been to engineering school? How easy is it going to be for them to do this without me? Because we are not going to build 350 projects by everyone being slightly different and slightly updated and slightly adjusted. So what I'm actually really excited about sharing with you guys tonight is designing for the rural last mile, but doing it at scale. And I think this could be so translated for any number of initiatives. I mean, there are 300 types of different stoves that could be used for these communities. There are a limitless number of water technologies. And not to say that those aren't all important different iterations, but I believe that if we are really going to move the needle, we need to have consolidation in the social sector. And so that means that we don't need to have 45 different bridge types and 40,000 different kinds of ideas floating out there. We need to be coming and coalescing in order to solve the big problems. And the way that Bridges to Prosperity is aspiring to do that is kind of through a model that's fivefold. First, I'll talk about standardization, talk about getting our teams equipped to do this safely, talking about how do we really move the most important and expensive materials, how we leverage partnerships. We're not going to do this alone. And some exciting culture of learning information I don't think anyone in this room totally knows. So maybe Ian. So standardizing the bridge designs. Again, thinking about scale. I really believe that going back into my master's thesis, I was trying to understand how much of a difference would it make if we were to say, well, we're going to have a fully saturated sand condition. What would an anchorage look like if that was the case? It's in the water table. It's pretty much buoyant. How would that influence the size of a dead man beam anchor compared to, a highly cohesive soil that has a lot of, 33-degree internal friction and really high unit weight? I want to translate all this because I have it all in pounds, so I'm sorry. That's all your fault. I don't know why Americans keep it, but I don't have any metric system in my brain. And it's about thinking in terms of the trade-offs. So when I was thinking about how can we standardize and how can we get this information into a protocol and a system of designs that we feel comfortable sending out into the world, it was about making the trade-off that was on the level of integrity. The design integrity that if I hand it off, it's going to be really conservative. That's what we've done. So our technical advisory board has taken that and run over the last 10 years. The designs that we produce for free online with lots and lots of different additional available materials. Those are all really circling around the idea that we are trying to make this a really robust structure. We do adjust materials. We get that question a lot. I'd love to talk about that. I think that's usually one of the biggest flags when people think about standardizing, is the idea that we are somehow not being locally appropriate. So I'd love someone to ask that. We can talk about it later. But this is allowing us to not only scale in terms of building, but when we want to maintain and to replicate structures locally, we absolutely cannot have every structure being entirely different with a different detail about how it connects. Because how are you going to send an army of people to go and inspect those? And then how do you go about getting them maintained? So, okay, so this is a good example. I always keep going off. So this particular project is also in Haiti, and it's in Chambellan. And you can't really see the structure, but it's one of those projects that I'm most proud of. When we think about durability and standardized designs and thinking about worst case scenario, Hurricane Matthew ripped through Haiti last October. And it was actually, I just moved here. I was like, different time zone, I'm still adjusting. I'm sitting there in class, and all of a sudden I get, I think it must have been a Twitter or something, like blow up, like there's hurricanes hitting mainland of Haiti, blah, blah, blah. And silence. Go and look at, who can I find? What's the weather? What's going on? All I can find out is that the eye of the storm has landed in Haiti directly over the isthmus to the west, which is exactly where we have just built 5 structures in the last 2 years. About 2 to 3 days later, I'm hearing reports 10-foot swells in the rivers. So, 3.5 meter swells in the rivers. We're reported 500-mile-per-hour winds on land, 80% complete destruction of all the homes and the businesses and the houses, and no reports from anyone coming in and out because there's one road to Jeremy, and that one road washed out. And so we're all collectively coming together, like, what are we going to do? We've got an amazing partnerships. We're working with CARE. We're working under DFID. What are they doing? We're on the phone. They've got much better intelligence. They're out in front. But we're still like, hey, how are our structures? Like, are people safe? Did something catastrophic happen? And I remember calling the chairman of our technical advisory board and being like, I mean, I hate to say this, but this is a beyond storm that we would have designed for. So I'm pretty nervous. This is the anticipation point. So we did end up getting boots on the ground, and we were able to do it very efficiently because, large part, thanks to our partners. We were able to get there, do a full inventory of all the structures. Within a couple of weeks, 3 of them were opened. The only thing that was essentially wrong was that they had been submerged, and there were tree branches and all kinds of debris that had piled up. So could have been a dam, but the water was in such a kind of more flash flooding event. It didn't end up actually aggregating and taking out any sort of lateral load. So going back to we do a 3-meter design freeboard on all of our suspended structures, dependent 2 to 3 on our suspension. That kind of conservative notion that I cannot tell you how many times people are like, why is the bridge so high? Why, what are you doing that for? Well, that just looks ridiculous. And it's like, yes, but. We are here to design something that's conservative. And we are trying to make something replicatable that is going to be able to serve in the worst of conditions in a place where, quite frankly, unless we came in to fix it, it's not getting fixed for a while, especially if it's structural damage. One of the other structures did have like a full deck, like pretty much deck all came out, had to redo the whole thing. And the last one we ended up entirely replacing. So I think it goes back to also thinking about what your commitment is. You know, it's the professional integrity and the ethics that we all sign up for as engineers. It's about life and safety first, but it's also about we are designing and building the built environment to serve people. The bridge is gone. That means that we owe those people to return and to try again and to do it better. And this particular structure was still standing. No one got hurt. But the river entirely navigated back behind the abutment, and so it would be unsafe. We went ahead and closed it. But I think when we talk about standardization, that's kind of why. It's about the kind of events that we aren't able to predict. And I think, quite frankly, because we don't have the same level of certainty around our waterway navigation in most of these places where we're working, you really have to be conservative. And this is actually a team that just got back, a Michael Baker-led team over in the U.S. And I was looking at the drawings a couple weeks ago and was noticing, like in the river photos, it was one of those quintessential, you could totally walk through it in construction. And I was thinking, my chairman back in the U.S., he's always like, Avery, you got to get out and get photos of rivers, because the only time you take photos is when it's dry. And I was like, well, let me pull up the drawings and just, how do we even aspire to think about how high the water would get? And it's actually quite interesting if you think about it. You get weird terrain. You've got a hill on one side. You got this cascading out to the left abutment, kind of a waterway that would end up, theoretically, that tower is going to be submerged, that pedestal anyway. And thinking about when we're considering freeboard design, how do we ethically do that when we know that we could not build the bridge here and get 3 meters? So kind of imagine you got it's about a 10% of span. 10% of span roughly is our tower height, and that's just predicated on thinking about a realistic sag value with having a cresting structure under dead load alone. So under live load it should settle out. How do you get this up high enough so you get 3 meter freeboard unless you're to literally just stick build your pedestals even higher? And so to go back to the technical advisory board and say, is that actually going to be a better design element? Doing another meter of height when you're thinking about a waterway that's going to be, in this particular design scenario, you're going to have the waterway coming through and around your pedestal. You're going to have a greater moment arm, significantly greater moment on that foundation if you're doing another meter higher, because I'll show you guys some details in a second. But essentially this is the point of rotation, and this is steel, and then this is tying back into the rebar, which we don't have the capacity financially or technologically to be able to do drilled piers. So we're not talking about being able to go into bedrock or to be able to do something that would really suffice criteria here. But how can you think creatively, especially around freeboard? So essentially what we're doing is saying, well, we believe that 2 meters of freeboard is actually a superior design alternative, because as the water cascades out, you're going to have a lower velocity out to the side, and frankly, you'd rather have that reduced moment. Anyway, I could really go down a rabbit hole here. So I thought I'd share with you, just pick something that wasn't geotechnical, because that's my background. So I was thinking about, okay, I got a bunch of structural engineers. What would they find kind of interesting? And something I think is super interesting is the evolution of towers. And I think this is really just one of 1,000 different things that we've iterated on over the years to get to a standard. But it's something that I think always brings up questions, like what could you do with this or what could you do with that? And when we're thinking about standardized designs, we really wanted to find a solution set that could be variant, but also learn from our lessons. This first suspension tower design was quite creative. So we're working on Honduras, and we hear downwind that there are a bunch of old telephone poles that have been left and abandoned, and they could be totally used for bridges. And I remember talking with Jeremy Johannesson at McNary Bergeron. He's like, "Oh yeah, we can do that. Let's do that." And I was in his office before he actually went down to build this, and he's like, "Yeah, it's getting pretty heavy," because we weren't able to really, in terms of the weight per capacity of this type of material, it's quite heavy in order to be able to get the structural capacity. And some cool, really interesting. We're really proud of the details. It's like a little foot. I didn't mean to go into that, but it's interesting. They're able to get it up. But when he came back, he's like, after action report, we will never do that again. As it was starting to be tipped and on the A-frame, it actually fell because of, just A, the weight, but B, at that time we weren't using scaffolding for erection. And the weight of that particular structure needed to be double backed, one beam or one member on the other one to end up acting as a composite. Was like kind of a never again. So the next iteration, we were in Guatemala, and there was a pretty significant supply of tube steel, and this time we're down with a guy from Arup, who many of you may have met, Manuel Contreras, one of our founders of the kind of movement here in Europe around Bridges to Prosperity. And we're sitting there tinkering, and we're like, okay, well, we could use steel. That would be a much higher capacity to weight ratio. And we could actually make it as simple as possible. All we're going to do is, why don't we design a pedestal footer detail that would literally just pocket. And so we can get the steel, put it in the pocket, put some quick cement in there, and it's going to be in the vertical. We'd allow for sorry, I get so excited, lots of movement. So you're pocketing the HSS tube into, we designed it as a 5-gallon bucket that ended up hollowing out and had all the steel around it. And then aspired to just plop it in there, and then to quick set it. We would want that quick set to crack, which would allow some movement, and that it did. So I think one of the lessons there was it was very difficult in practicality to actually get steel to pocket, because we're thinking about everything is being lifted by hand. You could certainly design a pulley system there. I can see Will up here really gearing in. He's like, I'm going to solve that problem. But we were really trying to think, what is going to be safe and standard and something that we could do all around the world. And that wasn't going to be it. So we moved on. And I think what's really allowed us to reach new heights and new spans and to be able to be standard has been able to have a moment hinge. So if you can kind of tell, I've got some drawings a little bit later that will help fill in the gaps. But our pedestal has just vertical bars that are tied together, and you have essentially a male and female piece that is just allowing it to rotate. This is all pre-welded. We try to work with local universities to get the welding done there, to also build capacity with what we expect to be quality welds. We don't currently do anything on site. Then you just end up coming in, you're bolting the bottom piece, which has already been embedded, with the top piece as you're bringing up and erecting the towers. And I think what's kind of interesting here is, as we're thinking about how do we go to scale and how do we build as many of these structure types as we need to, whether the tower is 8 meters or 12 meters tall, it's actually a really similar detail. And we've worked with engineering teams all around the world to help us get that rebar pattern set in such a way that, yes, it's really robust and it's a little, oftentimes very redundant, But going back to it's actually more important for us to be able to train our local teams to be able to build this and to do it consistently with a high level of quality than it is to every single time iterate back and forth and say, like, well, actually, that's too much bar. So that's really the reason why we're able to serve communities like Shamo and Haiti. We never would have been able to reach the tube steel would never be able to have the buckling capacity to span this kind of length. So this is actually allowing the movement, which is kind of fun. So in an earthquake event, even taking that a bit further, you're expecting there's actually a very flexible structure type, and that serves us tremendously well. Okay, so not only is it about designing, which is really fun, but it's also about building. And I think that one of the things I'm most proud of is we're thinking about big picture, who's going to solve the problem in Nicaragua. It's not going to be me, and it's certainly not going to be Ian. It's going to be Esteban Palma. Esteban joined our team in Nicaragua in 2010, maybe 11, and has been a champion. Here's a guy that we had a really great idea we're going to get into reinforced masonry towers. Notice I did not include that in the tower iterations. There were lots of other ones. And, you know, we just kind of did our after-action review, and the design team actually loved it. There's all sorts of efficiencies here. We know that we see CMU block everywhere. There's a way that we can quality control CMU block where essentially, I wasn't even touching it. Come on. So you drop the block, and if you're at arm's length, if you drop it, if it doesn't break, it's actually sufficient for just being a formwork. And other organizations have come up with standards of how do you do interesting kind of back-and-napkin ways of checking material quality control. So we're like, this is great. This is going to solve all our problems. We can do reinforced masonry everywhere, and we can really quickly check the quality. Whereas opposed to if you were to do a cast-in-place concrete tower, you'd, like, good luck trying to QC that. So Esteban comes back, and I remember in the same month, he's just built a 65-meter suspension bridge with reinforced masonry and something almost exactly the same span with steel. And he's like, Avery, never again. We are only doing steel. Because it's just like he's thinking about from a safety perspective, like how hard was it for him to be able to be doing, you know, 3 levels at a time, to be raising the scaffolding, et cetera. But these are the folks that have really made the organization great. It's not only folks like myself who love the designing part, but it's about going out in the field and getting your hands dirty and being creative and finding the people that are the tinkerers and are the ones that are going to be solving the problems and hiring them. That's what we've done. A big part of being able to train an army of people to do this is to understand that the culture of safety that we expect is far in excess of anything they've ever seen before. And I can say my experience in a rural context, like we're in Panama, for example. In a rural context, people are so used to seeing in Panama City, there's guys in like the vests, and they see hard hats, and they're like, oh yeah, we totally get that. But that's not how we do it out here. We're in the campo. It's like, no. Like the reasons that people do safe construction practices are so you get home safely tonight. And so when I'm trying to say that we are here to provide safe access, well, that's actually about our employees and our staff and our community members being safe when they come home, as much as it is the community member being able to be safe 20 years down the road. I really don't think I'm touching that. Come on. But it's also like, I think in terms of being able to train an army, if we have a reputation of building bridges as quickly as we can, as efficiently as we can, but we don't care about our people, and we don't care about how we design details to make them constructible, I think we're really missing the point. And I think that that's something that I'm really proud of, that our board of directors has taken a lot of leadership of saying, do this right or don't do it. I kind of went out of order, sorry. So training and repetition, a big part of why we standardize is to be able to have a repetition of details. And so thinking about what could the teams be doing before we show up. So before an industry team arrives, which I'll show next, like what has been done already is actually pretty standard and repetitious and things that they can just take photos. And we have an engineer coming on site to do spot checks on certain preset dates and times. But ultimately, our local crews, which do not include local engineers always, are able to do a lot of the substructure work without us. And I think that that's super exciting, because if you imagine, we could also use the same kind of design details for schools. You could do the same kind of idea around having standardization when you're thinking about doing hospitals or water systems. And being able to train an army of people to do things at a high level of quality, that's easy to do a QA program to, and you're repeating it, so you can then really be able to make sure that that is being understood from the on-the-job training. Super spot on. We think this is a really important part of what we do, is once we kind of working out details and new ideas, is getting industry teams on the ground to help our teams professionalize. And we just had a board retreat here in London a couple weeks ago, and the topic of the role of the industry team was hot and center. And if you think about being able to expand geographically, what better way to be able to get a culture of safety and to train an army of local staff than to have some of the world's greatest, brightest minds coming down, taking something that's been standardized, but helping translate that to a local context. And it doesn't happen in one project. For those of you that have done this, it takes, oh no. I think I might have it on a timer, I didn't realize that. Sorry about that. It's a really important part of what we do. So I figured by 45 minutes in, I had lost almost everyone to sleeping, so I thought I'd go video time, which I think some of you guys have probably seen this, but I tried. If it wasn't clear what we did already, this should help. And this should have sound. Mm-hmm. I think. Sorry. All sorts of IT problems, always my problem. So in the last 10 minutes, I kind of want to tell you guys a little bit more about the how. You've heard a lot about the why. You've heard a lot about kind of how I can noodle into the technical. But how do we really get this done? And something I think that I'm going to start talking more about because I'm so proud of it, and I never actually get to it in my normal talks, is how does that cable get there? I always get this like, oh, the cable's sure greasy. That was a pain in my butt. But how did the cable arrive is actually something that we're arguably one of the most innovative organizations in the world in terms of where we're getting our supply chain. We are taking cable off gantry cranes, getting it pulled down, load tested, spooled, put on containers, and shipped in bulk. And I was talking to our Bolivia program manager a couple weeks ago, and the government's actually asking, hey, could we buy cable off you? Because it's so expensive and hard to get that once you start thinking about it, you're like, yeah, there are, in terms of total project costs, if we were to just show up in Peru and build a bridge, something like a 10x difference between what we pay in an incremental cost distribution from our transportation, logistics, and supply chain per linear meter compared to buying it. So if we're really trying to figure out how to solve this problem, and all of you guys that have heard our price point and how we get involved, everyone's like, how is it so cheap compared to how everyone else does it? It's because we have a global ecosystem of capturing cable, whether it's right there in the Panama Canal and sending it to Nicaragua, or whether it's, oh, I moved forward. See, stupid thing. Pulling it off and then being able to send it from Houston down to Guatemala. Likewise, from Mombasa, being able to go into Rwanda. It's a really interesting way to be able to reduce our costs. And at the same time, going back to the redundancy, we are having so much redundancy in our cable. I feel weird things from engineers, but cable will never be our failure mechanism, period. If you think about it, there's two different types of cable. Maybe I'm going to weasel this a bit, but like you can take wire rope, but you've got a 6x19 lay. It's got 6 bundles and 19 strands that are having just a push and pull, and so it's hyper elastic. And we're doing those in redundancy of 6 cables at a minimum. So you start to think about that really, like say bursting is just implausible given our loading condition, and we do a factor of safety of 3. But what's also cool is that we grab steel out of oil and gas. So thinking about how to reduce costs for steel, and not all of our steel comes that way. Some of it's donated out of steel mills, but really trying to be innovative because steel pipe and steel cable are going to be the major costs that we need to drive down if we're going to try to be building as many structures as possible. And we scale not only through just saying we're going to show up and send you some materials and good luck, but through partnerships. Every time we work on a project, the community is there 100% of the time and 100% of the way. Some communities, that's a free labor. Some places it's not. It's all dependent on the local context. But those are the folks that are creating a bridge committee, and they're the ones who are helping us to understand why they want a project, who's going to show up to work on it, what they're going to be doing to maintain it. And they're the guys that are showing up for months before any of us come in to tip towers. So it is a big part of their investment straight up out of the project. We also work with local governments. And I think this is increasingly more important. Going back to the Rwanda example, think about 350 bridges. Those are projects that the Rwandan government is currently paying for and will continue to do so in an even more meaningful way. I recognize some of those guys. And we work with private industry teams. Going back to how are we going to create a quality of care and standard around our work, pulling in people that are going to poke holes in what you do and that are the smartest people in the world is a really good way to do it. It also translates to an inspiring, I think, folks in our industry to think about how amazing engineering really is as a career and how impactful the work we do every day really can be felt in one single project in 2 weeks. We've had the distinct pleasure of working with a range of amazing organizations, both here in Europe and in the UK, but also in the US. And if you can imagine trying to design a bridge with a bunch of these guys in the table, I promise you what we're producing today is pretty phenomenal. We did not do this in a vacuum. And we leverage partners with other organizations. Going back to that, we're never going to solve all of these structures alone, but we want to be a resource, and we want to help organizations learn to do what they do better and to encourage other folks to be thinking about connecting the rural last mile. We've also trained and worked with military folks, and including like the U.S. Navy Seabees and local military alike, thinking about who have dollars to spend. A lot of development work actually happens in the military. We're really proud of a lot of the partnerships we've had there. And in closing, I think the promise to tell you guys something you hadn't heard before is around our culture of learning. And that's something that really has been a pretty internal process and something we don't publicly talk about yet. But we believe that as an organization, if you can't fail and fail fast and fail frequently and have enough humility to talk about that, we're going to be in a very dangerous situation. And it certainly might reflect the fact that we design fracture-critical structures that are life-saving, but also, a lot of potential downside. and we're a young team. So if we don't learn from the people that we surround ourselves with, and if we don't bring in the best and brightest and learn from them, it's a terrifying situation that I wouldn't want to be in. So the culture of learning is actually the very center core of what we do every single day, as a team, as folks back in Denver, as a board of directors, as even thinking about those of you that have traveled with us. How important the calls are for us to learn from what we did wrong and how we could improve. I can't tell you how much time we spend thinking about it. But it's also about learning as what we're doing right and what we're doing wrong, and celebrating the successes. We just are finishing a 3-year randomized control trial. So understanding, we think intuitively these bridges make a pretty profound difference, right? And the other organization, Helvetas, they do this in Nepal. By the way, they're amazing. But they do this in Nepal, and they've spent 30 years evaluating how bridges impact communities. And we use their data all the time, saying, look, huge impacts in financial livelihoods, more women are employed, higher crop yields. But this is the first time an academic institution that's third party has looked at us, and we opened all the doors. Said, hey, here's how we do what we do. Here's how we pick our sites. Here's how we prioritize what we're doing and where we go. And 3.5 years later, the results are phenomenal. I believe it to be the single most important thing this organization has ever done, has been to understand exactly how much a bridge can change a life. What the University of Notre Dame team found is that in a randomized control environment, meaning that all else equal, the only reason they didn't get a bridge was because of a technical challenge, but they had the same need. They had the same kind of terrain, the same roughly geography and distance from healthcare centers and from markets, versus that got a bridge. For 3 years, they're calling every week. Cell phones to all the folks in the area. What was your household income this week? How many days did you go to school? And so on and so forth. 3 years later, we found out huge changes. So just for the economists that are probably not in the room, but theoretically could be listening, just imagine that if in the first year, every single person that lived in the community on either side of that bridge had 30% more income. How quickly is that structure paying itself off? And just that's the first year. And these structures certainly are here for much more than a year. And what was most interesting to me, and what I'm kind of intellectually really curious about, is that these are life and limb, but they're also like insurance. And so what we found is that the bridges are allowing people, and farmers in particular, to invest more. They know they're going to be able to go to a market. They know they're going to be able to sell the goods, so they'll spend more money on fertilizer. They're getting higher crop yields. They'll plant more area, but they're also more willing to get a job because they know they can get to it. And so what we're, as an organization, excited about is to think about, if you were to translate at a single community level what the impact of a bridge can have, imagine if we connected an entire country. And imagine if in Rwanda, the 1.6 million people that are isolated because of a lack of a bridge, imagine if they were all connected, what kind of economic stimulus that would have for the GDP. It's pretty phenomenal. So it's not only about learning to be able to tell the world, it's also about learning internally. So the last thing that we're doing that I'll talk about tonight is that it's not only about the 3-year randomized control trial, but it's also about having a real-time interface with a text message system that right now we're prototyping in Rwanda, which is super exciting. But we have field enumerators that go around and are sending questionnaires that are able to be much more efficient. We get real-time data. So literally on our Salesforce backend, my director of evaluation showed me this yesterday. She goes, send, and there's a question that essentially relates to household level income this week, and immediately starts getting responses like, Yago, which means yeah, accept, keep going. And so in real time, we're like, hey, did you miss school this week? Nope. Well, we thought you would. And what does that do to our decision making around where we're putting structures and what we believe to be doing correctly? I think it's pretty transformative. So in parting, I'm 2 minutes over, but it's a tremendous pleasure to share the stage this evening with Ian, and in general with iStructE, because I don't mean to go against the importance of the bridge, but if imagine a world where all of the people are connected, is going to take some of the same problem-solving skills that we've used in the last decade to figure out the structure type. And now I need to be having people thinking much bigger. Some of the biggest challenges that we have are on the system side to get these projects built at scale. So with that, I'm hoping to have a very lively conversation, because I see lots of friends in the room who built these things and probably have more to say than I do. But yeah.
Thank you very much, David.
Yeah.